Hello students, welcome to the new session. And this session, in the last session we discussed related to the spring mass system in vertical, horizontal in different cases, and also how it will be exist. Now in this session we are going to discuss related to combination of the springs. So see here, first we are considering two springs of a spring constant K1 and K2 are combined in series combination. When we are combined in series combination, what happened to the value of K? Then what about the time period and as well as frequency? That we are going to calculate here. Here I am considering two springs of spring constants K1 and K2 are attached to join to end. In this combination only we are saying that simply series combination. One end of this spring is joined to the another end of this spring. We know that the spring constant K depends on extension of the extension is inversely proportional to the spring constant. That is nothing but here you can observe the total extension in the springs. First spring is extended x1, second spring is extended in x2, and the total extension is x1 plus x2. Total extension is x1 plus x2. Now see here, this total extension is equal to, we can able to write total force into total spring constant into displacement. K is the effective spring constant or total spring constant. Then K is equal to what we can able to write, or X equal to what you can able to write, X equal to minus K upon K effective. X equal to minus K upon K effective. Similarly, X1 is equal to minus F upon K1. X2 similarly F upon K2. X2 K1. X1 K1 X2 K2, like that. Just put the values of x1 x2 x3 x1 x2 in this expression. So generally we have x equal to x1 plus x2. X value how much? Minus f by k effective. X1 value how much? Minus f by k1 minus f by k2. Means minus you can take common and cancel also, no problem. And minus f also you can cancel. The remaining 1 by k effective equal to 1 by k1 plus 1 by k2. 1 by k1 plus 1 by k2. Then finally 1 by k effective we can able to write LCM k2 plus k1 upon k1 k2. Cross multiplication error. K2 plus k1 upon k1 k2. Then totally the k effective value what we can able to take, k1 k2 upon k1 plus k2. This is the effective spring constant when we are connecting in series combination. Now what about the time period? Now time period is going to be 2 pi into under root m by k effective. M by k effective. What is the value of the k effective is m by k1 k2 upon k1 plus k2. K1 k2 upon k1 plus k2. If k1 is equal to k2, then what is the value of the k effective? Is going to be k1 k into k by k plus k. That is going to be k by 2. Then the time period is going to be 2 pi into under root 2m upon k. 2 pi into under root 2m upon k. In case if we are connecting m springs on n number of springs in series combination, n number of springs. N number of springs are connected in series combination. Then the effective value of the k is going to be decreases to k times. Effective value of the k is decreases to k times. Then time period is increases to root n times. Time period is increases to root n times. How? Time period t equal to 2 pi into under root k by means nothing but m into n upon k, where n is nothing but number. N is nothing but number. How many number of springs you are connecting in series combination? Identical. N identical springs. N number of identical springs. Identical means all are having same value. Then the time period is going to be n times. In case of vertical, if you are connecting in horizontal situation, how it will be? Means this combination like this. If you are connecting two springs like this, and which combination it is? Yes, of course, the combination is series only. The combination is series only. Then what is the value of the k effective? Yes, k1 k2 upon k1 plus k2. Either in vertical plane or in horizontal plane, the value of the means if you are connecting, if you are joining end to end, that combination we can say that series combination. Which combination? Series combination. Okay, let's see here parallel combination of the springs. Parallel combination of the springs. Here we are considering again two springs of spring constants k1 and k2 are joined parallelly. Means parallelly means nothing but two ends are compulsory. Two ends of the spring are joined to the rigid support, either body to the support. Two springs must be participating in the connection, or anything, even capacitors, resistors, rod, whatever. Series parallel means two ends come directly joined to the source or directly joined to the rigid supports. So that's here. See here, two ends are directly joined, means two ends of the spring joined to here, two ends of the springs joined to. So that's why this is comes to parallel combination, k1 and k2. Now, so see here what happened to the extension. Extension is equal. Extension is equal, and the weight of the body is nothing but what you can say that the force, the restoring force in the spring, first spring kF1, restoring force in the second spring, which is equal to total restoring spring. If you have one spring, then you may have one restoring force. If you have two springs, then you may have two restoring force, and you may get that out. Why we are not taking the restoring forces there? Actually, those total restoring forces means those that can be helpful to get more extension, but this not. This is shared. This is work shared. So see here, what will happen? If total extension means nothing but extension in each spring is same. That's why total extension is equal to same. In case of parallel combination, all springs are extending equally, equal extension or same extension. Equal extension or same extension. That is nothing but we can able to write total k effective into extension in the first spring, total extension, and k1 k2. Hope you understand this restoring force, total effective into total extension, but total extension, all is extension is same. So you can able to cancel minus x, then the k effective, how much you can get? K1 plus k2. Easy na? Parallel easy. Series getting 1 by k1 plus 1 by k2 LCM k1 plus k2 by k1. Okay, easy. So now the time period is going to be 2 pi into under root m by k effective. The value is going to be 2 pi into under root m upon k1 plus k2. 2 pi into under root m upon k1 plus k2. That is the value of the time period. Now in parallel combination, what happened? See here, if k1 is equal to k2 is equal to k, Now the K effective value is going to be 2 times. So then what happened? 2 pi into under root m by 2k. Nothing but when the springs are connected parallelly, then time period is decreases. Time period decreases. Time period decreases. Whereas we are connecting in series, time period increases. See here we are considering n number of identical springs. N number of identical springs are connected in parallel. Connected in parallel, then K effective is going to be n times of K. K value is increased by n times. Then time period is decreased by root n times. How? 2 pi into under root m by nk. What about the frequency? Frequency increases by root n times. In case of parallel combination, frequency increases, time period decreases. In case of series combination, time period increases, frequency decreases. Time period increases, frequency decreases. And let's some more we will see here the combination, parallel combinations, series combination, like that, whatever. So here I am taking a body which is connected between horizontally between two means like this mass here. Which combination is this? Yes, of course. Which combination? Series combination. What is the value of the K effective? K1 plus K2. Very good. Next, see one more. Yes, which is connected between a mass M is connected between two springs of a spring constants K1 and K2. Two springs of spring constant K1 and K2. Then what about the effect? Means first of all tell me which combination it is this. Which combination? Series or parallel? Think. Series or parallel? Yes, of course. Series na? If you are taking series, completely wrong. Yes, it's parallel. How? What I told you first. Parallel combination means compulsory every end of the spring which is connected to the rigid support. See here, first spring, rigid support, another end into the body, rigid support, another end to the body. Nothing but the combination is parallel. Which combination it is? Parallel combination. This combination is parallel. Parallel combination means what is the effective value of K? K1 plus K2. And one more thing, parallel combination. The extension in the one spring is equal to compression in the another spring. Extension in the one spring which is equal to compression in the another spring. Then that is also we can means one extension plus x, another one compression minus x, that should be equal. Then the combination we can say that parallel combination. Parallel combination means extension in one spring which equal to compression in the another spring. Extension in the one spring is equal to compression in the another. Means the displacement, for example, which is extended by x, then how much it is compressed? X compression. So that's why the combination we can say that which combination? Parallel combination. The effective value of K, K1 plus K2. Okay, let's see one more example. Yes, I'm connecting three springs like this. Yes, K1, K2, K3. K1, K2, K3. Which combination it is? Which combination it is? K1, K2, K3. See here, The extension in the 1 and 3 is equal to compression in the 2 now. Extension in 1 and 3 is equal to compression in 2. So that's why this combination is again parallel. Which combination? Parallel. Then time period is K value is K1 plus K2 plus K3. Then time period is 2 pi into under root m by K1 plus K2 plus K3. Here time period again in this 2 time period is 2 pi into under root m by K1 plus K2. Okay. See one more. Yes, which combination is this? Tell me which combination is this? Series or parallel? Series or parallel? Comment series or parallel. You can comment it. Yes. Parallel combination. Extension in M is less than extension in this. So both extensions are different. Sorry, say extension in this is equal to compression. So again, what is the time period of this? Same. Next, see here. Which combination is this? Which combination? K1, K2, K3. Which combination here? Yes, again, which combination? Parallel combination. The value of the effective is this. Here you have 4, here also 4. How many? Note one thing you have to remember. 2 points you have to remember in case of parallel. First point, extension in one spring which is equal to compression in the another spring. That is parallel. Next one, all end of these springs, 2 ends of these springs must be connected to the support or the body. Must be connected to the support or the body. Then the connection only we can say that parallel combination. Very, very important. Please practice it properly, then you are getting good score. Here one more question is there. Here 3 identical springs are connected like this. One is like this and like this. Then what about the effective value of the K and what about the time period? That is the question to us. So that is the question to us. Okay, first try to get the value of K, then you can able to do anything. So which combination it is? Yes, this is no. These 2 are in parallel, the effective with this in series. Yes, of course. The 2 are in parallel, the effective is in series. So this is K and the remaining these are in parallel, means the effective is going to be 2K. The effective is going to be 2K. Then what is the value of the total effective? The total effective is K into 2K upon 3K. K plus K. K cancel. Then finally K effective is goes to 2K by 3. 2K by 3. Then time period is going to be, yes, 2 pi into under root m by K effective value. That is equal to 2 pi into under root. What is the value? 3m upon 2K. 3m upon 2K. Third option. 3m upon 2K. Okay, let's see here one more question. There is a spring of a spring constant K is attached here and mass M is attached here like this. So then what is the time period of oscillation? Yes, what is the time period of oscillation? T is equal to 2 pi into under root M by K. Right now? Yes. If we are doing it, that is wrong. Because the answer is not this. The answer for when you are taking the spring is here and it is a rigid support, then no change in that, because at that time extension is equal to this. But if it is the case, then why we are discussing this, right? Yes. So the case is here. See here. Here we are connecting to the pulley. So sometimes just leave the spring and as well as this. Just to see here. For example, here I have a pulley. And here something, this is another one something. So now here what happened, here I am attached to the mass M. For example, if it is getting extended and this is also gets extended or not, it's generally what we are doing, just you are trying to pulling it. If we are pulling here X, then how much here it is happened? How much here is the extension? You have to tell properly. You have to tell properly. If we are pulling it is by x, how much it is going to be extended or how much it is going to be displaced? Yes, automatically this is gets x displaced and this is also gets x displaced because here it is connected by the two springs now. Yes, that means here if t gets x by 2, sorry, if it is a total displacement is x, total combination of this is x, then this is how much it is gets x by 2. Combination means actually what I am saying here, if it is gets x displaced, then the block will get x displaced by 2x. Block will be gets displaced by 2x. Because here x displacement, totally 2x displacement. If the total displacement is x, here how much it is gets? X by 2. So that is only here also we are taking. So here what I am considering, the total displacement of the block is x. What is the total displacement of the block? Total displacement of the block is x, means that means this side it is displaced by x and this side it is displaced by x by 2, this side it is displaced by x by 2, total displacement is x. Now how much the spring is gets displaced or how much the extension in the spring? The extension in the spring is goes to half of the displacement of the body, because the body is connected to 1 but the spring is connected to 2. The spring is connected to 2. So that's why here it is the extension x and here it is going to be half of the value. That is going to be half of the value. Now what is the spring force here? Or that for spring force only we are named as restoring force. The restoring force equal to what we can able to take? Yes, 2x by kx by 2. The restoring force equal to kx by 2. And one more thing, here you have the pulley. On the pulley upwards F restoring force is acting and downwards 2 tensions are acting. Downwards how many tensions? 2 tensions are acting. T and T. That means the restoring force equal to what you can able to write? The restoring force equal to what you can able to write? 2T. That means 2T equal to kx by 2. Then restoring force T is equal, tension T is equal to kx by 4. Tension T is equal to kx by 4. Actually everywhere minus is there. Here how much? mg. Here T. So that is mg is equal to minus k by 4 into x. Minus k by 4 into x. So then what is the value of the k effective? Means if you are taking the value of the k effective will be goes to k by 4, because you have to comparing you have to compare from the acceleration equation. Then the k effective is goes to total k effective will be goes to k by 4. Then time period of the pendulum or the time period of the spring mass system is going to be m by k by 4. So then that is goes to 2 pi into under root 4m upon k. So here this is the value of k effective, that is equal to this much we are getting. This is the time period of the spring mass system. Let's see one more problem. Similar problem but not similar. See here. Here again the extension, if here x and here x, here how much? Here x, totally. If the extension in the spring is x, and here it is going to be x by 2. Here it is going to be x by 2. Or else take here, if the extension of the mass is x, if the mass is coming x displacement down and the spring is getting extended by 2x. The spring is get extended by 2x. See very clearly. If it is extended by, pulley is extended by x, that means the spring can get here and here. Total extension is going to be 2x. Now here how much tension? T tension you can take, and here the restoring force is acting. First you can write the restoring force. The restoring force equal to minus k into 2x. The restoring force equal to minus K into 2x. Then tension is equal to, the tension in the spring or the tension is equal to, T is equal to what you can able to write? 2 times of restoring force. 2 times of restoring force. And that is equal to minus 4kx. Minus, the tension is equal to minus 4kx. The tension is equal to, we can able to take the net force is equal to minus 4k by x. Net force is nothing but mass upon acceleration, right? Mass into acceleration. Then acceleration is equal to k by 4k by m into x. And this 4k by m is nothing but we can able to take omega 4k by m. Then omega equal to 4k by m root. Then time period equal to 2 pi into under root m by 4k. Here also same. This is you are getting as net force m into a minus 4pi. Then a is equal to minus 4 by m into x. Then time period is going to be 2 pi into under root m by k by 4, and this is m by 4k. M by 4k. So very important and as well as easy. So here see here what happened, k value is, if you are connecting like this, k value is decreased by 4 times. If you are connecting here, k value is increased by 4 times. K value is increased by 4 times. See one more important application, that is regarding reduced mass. What is that? Reduced mass. What is this reduced mass and how we can take that? Let's have a look. Reduced mass is nothing but, for example, here I am connecting, here I am considering a body of mass m1 and another body of mass m2. Both are joined by a spring of a spring constant k placed on a smooth horizontal surface. Where? Smooth horizontal surface. Now both masses are compressed and released, or both masses are extended and released. Then they are making oscillation. Then what is the time period of oscillation? What is the time period of oscillation? So to get the time period of oscillation, here we need to take the reduced mass. We need to take the reduced mass. So means here k is k only, but how the masses are connected, that is important now. Yes, the masses are connected. So that's why the mass or the effective mass only we are named as, reduced mass. What is that? Reduced mass. The value of the reduced mass equal to, we can take m1 m2 by m1 plus m2. The reduced mass we are representing with letter mu, that is equal to m1 plus m2 by m1 plus m2. Now the time period is going to be 2 pi into under root mu by k. 2 pi into under root mu by k. So now what is the total? Time period is going to be 2 pi into under root m1 m2 upon m1 plus m2 into k. m1 m2 upon m1 plus m2 into k. This is the time period of this. So this masses we are named as simply reduced mass. How we are getting? To get this value, there is a much calculation is there, and that you can take. Next, similar cases. One more similar cases. There is a heavy vehicle, means there is nothing but a train or bus or whatever. On its surface, there is another mass is kept. The mass is m here, and this vehicle mass is capital M here. Then what about the time period of oscillation? Means here also we need to take reduced mass, m into m by m plus m. M into m by m plus m. Then time period is going to be same, 2 pi into under root m into m by m plus m of k. So that is the value of the reduced mass. And in case if you are considering the third situation, there is a one circular pipe. Here we are considering two masses, means frictionless, means they can able to easy to move, and the two masses are connected by the two springs of a spring constant K1 and as well as K2. K1 and as well as K2. Spring constants K1 and as well as K2. Now what about the effective value? Here only one spring, so that's why no problem. Here also only one spring, so that's why no problem. But here two springs are there, two masses are there. Then yes. So nothing difference here. First you can take masses. Mass reduced mass M1 M2 by M1 plus M2. How much? M1 M2 by M1 plus M2. Then take effective value of K. Which combination? Series or parallel? अरे देखो series or parallel? Series ना? नहीं देखो extension in one spring is equal to compression in the another spring. That's all. Parallel. Which combination? These two are parallel. Extension in one spring is equal to compression in the another spring. Or else one more thing, both the springs are joined to the both bodies, nothing but parallel combination only. So then the effective value of the K is going to be K1 plus K2. K1 plus K2. And in case same condition, if the bodies are connected like this, which is similar to this case, M1 body and here M2 body, both are joined by the two springs of spring constants K1 and K2. This is K1 and this is K2. So then again same mu M1 M2 by M1 plus M2. Now what is the time period? Time period is 2 pi into under root mu by K effective. Mu value M1 M2 by M1 plus M2 into K1 plus K2. So that is the value of the spring constants. So it is very easy and just you have to practice it properly. Then you can able to do any problem from the spring constants.